When we talk about the history of programming, we almost always focus on how fast things change, how fast it evolves. It's hard to, stay on top of things. But actually, things do not always change in the same direction. There are things in computing and programming in particular that go like, that tend to swing back and forth over the years. If you disagree, I would imagine that you haven't been in programming for more than a few years because the pendulum is slow. Some things take a long time to come back. But eventually, some old person in the room is going to say, hey, this is how we did things, 20 years ago. So one thing that is happening now is that after a big push for dynamic languages around the 2000s, now we are getting back into static languages again, or at least, there is a lot of effort to put some static type checking into dynamic languages. And many people are super excited about that. And even Ruby, that is like, the most dynamic of them all. In Ruby 3, we got RBS. That is a way to put some static typing into Ruby. How many of you are using RBS, or at least you tried? A few people, not many, okay. But you don't count because you use a mega drive to code in Ruby. I mean, you are niche. But okay, not many people. I do understand because, RBS might look suspicious, like what is happening here? Are we turning Ruby into a static language? Are we forgetting all about duck typing? So let's talk about Ruby and types. Types in particular, because types are confusing, to be honest. If you look up type systems on Wikipedia, you get a lot of categories. And a lot of these terms are essentially trouble generators because they end up being creating misunderstanding, like static versus dynamic. We all use these terms, but when we talk about static languages and dynamic languages, if I were, an annoying nitpicker that I totally am not, I would say that these terms don't mean much, if anything, because it's not the language that is static or dynamic. It's more like the typing that is static. And if I were even more pedantic, still not me, I would say, no, that's not even that. It's the type checking that is static or dynamic, right? It's not the types. It's about the type checking. And in particular, so this is the point. Your language is checking your types at some point. Okay? Pretty much every modern language is going to say, hey, you have a string here. Let me check that this method you're calling is actually looking for a string. When does that happen? Does that happen before runtime? That's static. So static is before runtime. Your language is checking your types. Your language means something is checking your types, usually a compiler, right? That's all it means. It doesn't say anything about, declaring the types of variables. Only if somebody's checking your types, this somebody needs enough information to actually do the checking. And that, in turn, usually means that you have to, put in type signatures. So this is C#. It doesn't matter what this code does. What you immediately see is all these type signatures, all these type declarations. This is, the type of these arguments. This is a function that returns a list of integers. There is that, but there is also some case, even in this function where you don't do that. For example, if you know some C#, you can deduce that variable n is an integer, but you don't need to declare it because the compiler is finding out. It's finding out on its own. And some languages push this idea of type inference quite far. So this is the Crystal language. And this is a line that initializes a map that maps strings to lists of integers. And make no mistake, Crystal is fully statically type checked. But you very rarely, if ever, declare your types, because the type inference is quite good at that. So that's static type checking, as opposed to dynamic type checking that is happening at runtime while your program is running. And because of that, this is Python. You probably don't need to declare your types, simply because at runtime declaring your types is redundant. Python can just look at the values and say, yo, this is an integer, you're using it in a non-integer way, I'm gonna give you an error. That is the difference. Everything else is kind of like a side effect of that. Like, how come, statically type-checked languages tend to be compiled? Well, somebody has to check the types, right? A compiler is good for that. It's just a good fit. It's not mandatory, but it's a good fit. How come, dynamically type-checked languages usually allow you to assign values of different types to the same variable? Well, you don't need to specify the types of your variables because nobody's going to check them anyway. At that point, why introduce additional constraints? Let's just make variables, like free containers that can contain anything. Everything else is a consequence. The basic idea is, when does type checking happen? And by the way, I'm going to say static languages and dynamic languages because I'm not that nitpicky. It's just, the alternative is a mouthful. As long as we know what you're talking about. Again, confusing terms. And because there is another pair of terms that I want to talk about. This strong and weak typing, because I hear these used in a confusing way so often, sometimes from myself. Many people sound so very Trumpian. Many of us programmers use these terms to mean static and dynamic. That's not what they mean. To give you a better idea of what strong and weak are supposed to mean, imagine a language that does no type checking, okay? No type checking at all. Assembler doesn't count. That's all ones and zeros. Can you think of a language, high-level language, that doesn't do any type checking? It's not a trick question. I actually had to actively look for it. And I looked for a while. I had to go back to the 70s to find the fourth language. That is a weird stack-based language. This is a line of fourth. Here is what it does. When you type a number just like that, fourth pushes that number to the stack. It has a global stack. So it's push 3, push 4, push 5, push 6. Then the plus operator pops the top two numbers from the stack, adds them together, and pushes the result back to the stack. So now there is 11 on top of the stack, okay? And the dot operator pops the top of the stack and prints it on the screen. So now we get 11 on the screen. Fair enough. But if you change those two operators with their uppercase D variety, that means pretty much the same thing, only use what fourth calls double numbers that are still integers with twice as many bytes. So you get something that you probably do not expect, because now you're pushing those numbers on the stack with, I don't know, 4 bytes. It's platform dependent, and you read them back with 8 bytes. And Force doesn't care. Don't worry, man. It's it's bytes, all right? It's all bytes. And that is a language that doesn't do type checking. But most languages today do some type checking. They are more strongly typed, right? I mean, some of them are strongly typed relative to Force, but still relatively weakly typed. Ladies and gentlemen, JavaScript, it's always good for that. Always good for this, it's like, ta-da. It's, you subtract a number from a string, right? And JavaScript is like, I know what you're doing. That string looks like a number, eh? So, just goes forth, JavaScript. Other languages are even more strongly typed, like Ruby. Ruby doesn't allow you to do that. Slap on the back of your hand, what are you doing here? I'm not going to do that. You got to do it yourself. Okay? Then it's okay. So that is the point of strong and weak typing. It's still about type checking, but it's not the same as static and dynamic. Static and dynamic is about when does type checking happen. Strong and weak is more about how much type checking does happen. And by the way, I would actually not use these terms because they are used by different people in different ways. So it's just confusing. I do use them. Call me out when I do. I'm gonna do that, I'm pretty sure. So a lot of this swing, right, that we're living now in the last 10, 12 years, from static back to dynamic, a lot of it is about taking languages that were designed to be dynamic and adding some static type checking to them. And there are a few ways to do that. 3 ways I can think of. One is transpiling. Transpiling is better understood with an example. And I would say the go-to example these days is TypeScript. So TypeScript looks like JavaScript, only it also has type signatures like that. So the TypeScript compiler can check those types and then compile this code to JavaScript. That's why it's a transpiler. It's a compiler that translates to another language. So that's one way to do it, right? You essentially build a new language on top of the existing language. Another way that preserves the language, doesn't require you to build a new language, is to have annotations. Essentially, the idea is you don't have a compiler, probably, that's fine, you can have a type checker, but this type checker still needs that type information, so you put that type information in annotations inside your code. And we do that in Ruby with Sorbet. Sorbet is right now the most popular type checker for Ruby. And it works by asking you to put annotations in your Ruby code. So this function here is kind of like the function we've seen earlier on, the TypeScript one. Doesn't really matter what it does, but it's decorated with these annotations that, Ruby being Ruby, are in part embedded in comments, and in part they are a small domain-specific language to declare types. And now that we have this, we can ask the Sorbet type checker to run on this code. And bask in the glory of a job well done. Or if we have errors, like for example here, instead of passing two strings to that function, I pass a number in the string. That's incorrect. And now Sorbet is giving me a type error, very detailed, very explicit. And a third way to do this would be to do pretty much the same as this, but instead of putting your type information into annotations, you put them into external files, signature files. And that is what RBS is doing. So RBS, the idea of RBS is you got your Ruby code. It's regular Ruby code. Here it's a duck class. It has an attribute, distance walked, that appears to be an integer. It has a few methods, a walk method that takes a distance and increments the distance walked, a quack method that quacks, it returns a string, it takes a Boolean that is optional because it has a default value, just regular Ruby code. But then you have a parallel RBS file that gives, let's say, a different take on the same code, on the same class. So this is the RBS file. And the different take is that it doesn't include any implementation. But in exchange for that, it includes type information. So we can see that the attribute is an integer, and the walk method takes an integer and returns untyped. That means it returns nothing, or more precisely, we don't care what it returns because every Ruby method returns something, actually. And the quack method takes an optional Boolean and so on and so forth. And now that you have these two files, you can take this information, pass it through a type checker. The default RBS type checker is called steep. Or just load this stuff into your IDE. This is RubyMine. It already has good RBS support. So it's picking up the files from the RBS, the types from the RBS file, and putting them in your Ruby code as documentation. So, you know, better documentation. And I assume better navigation, better autocomplete, all that stuff, right? So this is what we have, and we are just about at the okay, but stage of this presentation when, yeah, that's nice, but do we want to do that? I mean, is that a good idea? Or, you know, because it smells an awful lot like static, you know, static languages. And this is a sensitive topic. I'm aware of that there is a Cold War going on in the programming community. It's a never-ending story, and there is a debate going on about static versus dynamic. And the debate is, frankly, very poor. It's a terrible debate. I mean, the arguments I see for statically type-checking your code or dynamically type-checking your code are terrible. I'm sorry. Everything is unconvincing. Like, oh yeah, static type checking, it catches bugs. So yeah, well, I mean, that's weak sauce. It's not going to, you know, to sway anybody. Or dynamic type checking, more expressive, more weak sauce. You are pouring all that weak sauce all over me. Stop doing that. So I'm aware that I'm not nearly as smart as the people taking part in this debate. I say that unironically. I'm not as well read. I do have something that they don't have, that is love, because I love Ruby, but I'm coming out a little here. I honestly love coding in Java. I feel so comfortable. Don't ask. So I don't claim to be, you know, very knowledgeable. You know, being the guy who likes country music and rap music, maybe I am the person who can contribute to make a comparison, actually. I'm not super biased, at least. So I would try to give you one benefit of static and one benefit of dynamic type checking. And clickbait, they are not what you think they are. These are not the usual arguments that are the usual weak sauce, okay? So, one major benefit of static type checking. Many programmers will tell you, yeah, static type checking makes your code easier to understand. That's true. It's nice. For yourself, for your teammates. But I would say that the game changer is that it makes your code easier to understand for computers. Yes, that means catching a few bugs. It also means better autocomplete, it means better navigation, it means better documentation, it means better tooling. And to be honest, again, Ruby is my go-to language. But to be blunt, you don't know what automated refactoring really feels like before you do it in Java, in a good IDE, or C#. It's like a whole different planet. It's amazing. If you never tried that, you owe it to yourself to do it once. It's like, sometimes I don't even write code. I just refactor, and it changes my design in a very deep way, and it's reliable. You say, you know, I don't like this hierarchy. Let's not use inheritance here. Let's use delegation. That's a pretty deep change. And it applies it to, you know, hundreds of lines of code all over your system. It works. It's quite amazing. I would say I'm not, you know, I'm not against using Vim. I use it. It's great. But sometimes in some corners of the programming problem, there is a more and more complicated code to deal with. So we need more and more powerful software programming tools. That's when we need this. And that means that static type checking is good. Honestly, it's not just not actively evil. It's a good thing sometimes. On the other hand, dynamic type checking, one major benefit, and this one I never hear. So either I'm hallucinating here or you heard it here first. I think that dynamic type checking works well with a distributed heterogeneous network. I talk about the internet. I'm not that old, but I still remember clearly when it was so hard and complicated to have a local network with like 3 services calling each other. It was a hard problem. And now we have a planet-scale network with millions of services calling each other, and it kind of works on a good day. It's amazing. It's amazing. And the reason why we did this, I think, is that we found good design guidelines for this stuff. And one such guideline is called Postel's Law. Postel's Law, you probably follow it, even if you don't explicitly know about it. One of its formulations is, imagine that you are an actor on a network, talking to other actors that you have no control over, written by other people in other technologies with different life cycles. In that case, when you send data to others, be strict, be conservative. You want to be precise. You stick to the contract. You set up a contract. Stick to it. But do not expect the others to do the same. When you get data from elsewhere, be super tolerant. Be open about it. You see a field that you know you've never seen before, you don't know what that is, just ignore it. That is exactly, that second part of Postel's Law is exactly the opposite of static type checking. It's the opposite. Because static type checking is a contract, right? Contracts are strongly coupled by definition. That's what a contract is. You don't want contracts when you are on a heterogeneous distributed network. That is where most modern interesting problems are. And in fact, people have been trying for a long time to stick static type checking on top of the internet, and they failed. They didn't just fail, they failed miserably, like the SOAP standards, the WS standards, very costly mistakes. So, dynamic type checking is good, as in indispensable. Of course, you can communicate from a Java program using JSON, but you need a translation layer. For a small program, the translation layer becomes the core of the problem. You need tools that match your problem. And dynamic type checking does match the problem of having, this heterogeneous environment with different life cycles. So it's not a matter of, do we want static type checking or dynamic type checking? We need both. We have no choice, actually. I would say we never did. We're under the delusion that we can choose. So one of the best pieces of advice I ever got in my career as a programmer is this one. I don't know where it came from. Maybe the pragmatic programmers, I'm not sure. They said, master at least 2 languages. One static, one dynamic. Because, different ways to use them, different problems, opens your mind, different approaches. Cool. Maybe it's time to start thinking about mastering one gradual language. One language that allows you to do some static type checking when you need to, and dynamic type checking when you can. Or the opposite, depending on your biases and inclinations. And I think that RBS is a step in that direction. I mean, I have no idea whether it will stick. Maybe we'll keep ignoring it. But it's an option. It's nice to have it. I would suggest you try it, especially if you want these 2 use cases. I'm just trying. Again, I'm still understanding how to use this tool. One use case is you have a big project, and I mean big as in people are getting confused by the types. You're starting to get type errors on a big scale. And the other one is you're writing a gem, because when you write a library, somebody's going to call that library. You don't know your callers. Maybe you want to be strict in the data you send to your callers. That's the first part of post slow. So it's nice to, give them a type declaration like that. This is going to be this, exactly. And yeah, who knows what will happen? It's an experiment. We like experiments, don't we? Kind of things. Thank you. Thank you.